Welcome back to the channel. Welcome back to Excel Island, where the goal and objective is to learn and master Python over the next 100 days. And today is day 49. We are on our 7th course out of the 9 course in the career track, Data Analyst with Python on the Datacamp platform. So the ninth course is teaching us all about Introduction to Statistics in Python. So we started learning all about statistical analysis with the Python for Python data analytics too. You get it now. So we're on the course or introduction to Python, as I said earlier, and we are on chapter 2 of the course. Sorry, chapter 3 of the course. So we are looking at what is called the central limit theorem in the course. We are learning all about the central limit theorem. So let me just start sharing my screen real quick so we can continue from where we stopped on day 30 day 48 rather. So we built a couple of stuffs with this. We've done a couple of analysis using the data analysis in statistics. So we looked at a couple of various analysis in Python. So you can catch all about this on the previous live stream on the channel where we actually started this statistic analysis in Python. If I go up here a little bit, you can see we started from summing statistics. So we went over to random numbers and probability. Then we are on mode distribution and the central limit theorem. So for each of the chapter, we did a couple of analysis and projects and challenges just to implement what was covered in the lesson. So without any other delay, we're just going to continue from this central limit theorem. So on day 48, we actually learned all about the normal distribution and what normal distributions is all about. So just go ahead to the previous lesson to understand the different concepts covered in this lesson. And that was when we built a couple of charts and histogram like this to answer some key questions. And we also did some probability calculation also. So also we've learned all about these our libraries. We learned all about pandas, numpy, matplotlib, or different libraries in sci-fi like uniform, binom, and num. So just go ahead to the previous lesson or start from day one and follow along so you can understand what this bunch of line of codes are doing. So also the data sets that I've used or continue to be using is already linked under the YouTube description. Just go ahead with the link in the description and have access to the data sets to also practice all what we've done here. So let's move ahead to the central limit theorem and understand the concept behind the central limit theorem. So hopefully we are going to complete this chapter 3 in a couple of lives, probably next live stream or next 3 live streams. Then we'll go ahead to correlation and experimental design before we start building a couple of projects.
Now that you're familiar with the normal distribution, it's time to learn about what makes it so important. Let's go back to our dice rolling example. We have a series of the numbers 1 to 6 called die. To simulate rolling the die 5 times, we'll call die.sample. We pass in the series we want to sample from, the size of the sample, and set replace to true. This gives us the results of 5 rolls. Now, we'll take the mean of the 5 rolls, which gives us 2. If we roll another 5 times and take the mean, we get a different mean. If we do it again, we get another mean. Let's repeat this 10 times. We'll roll 5 times and take the mean. To do this, we'll use a for loop. We start by creating an empty list called sample means to hold our means. We loop from 0 to 9 so that the process is repeated 10 times. Inside the loop, we roll 5 times and append the sample's mean to the sample means list. This gives us a list of 10 different sample means. Let's plot these sample means. A distribution of a summary statistic like this is called a sampling distribution. This distribution specifically is a sampling distribution of the sample mean. Now, let's do this 100 times. If we look at the new sampling distribution, its shape somewhat resembles the normal distribution, even though the distribution of the die is uniform. Let's take 1,000 means. This sampling distribution more closely resembles the normal distribution. This phenomenon is known as the central limit theorem, which states that a sampling distribution will approach a normal distribution as the number of trials increases. In our example, the sampling distribution became closer to the normal distribution as we took more and more sample means. It's important to note that the central limit theorem only applies when samples are taken randomly and are independent. For example, randomly picking sales deals with replacement. The central limit theorem, or CLT, applies to other summary statistics as well. If we take the standard deviation of 5 roles 1,000 times, the sample standard deviations are distributed normally, centered around 1.9, which is the distribution standard deviation. Another statistic that the CLT applies to is proportion. Let's sample from the sales team 10 times with replacement and see how many draws have Claire as the outcome. In this case, 10% of draws were Claire. If we draw again, there are 40% Claires. If we repeat this 1,000 times and plot the distribution of the sample proportions, it resembles a normal distribution centered around 0.25, since Claire's name was on 25% of the tickets. Since these sampling distributions are normal, we can take their mean to get an estimate of a distribution's mean, standard deviation, or proportion. If we take the mean of our sample means from earlier, we get 3.48. That's pretty close to the expected value, which is 3.5. Similarly, the mean of the sample proportions of Claire's isn't far off from 0.25. In these examples, we know what the underlying distributions look like, but if we don't, this can be a useful method for estimating characteristics of an underlying distribution. The central limit theorem also comes in handy when you have a huge population and don't have the time or resources to collect data on everyone. Instead, you can collect several smaller samples and create a sampling distribution to estimate what the mean or standard deviation is. Now, it's time to practice utilizing the central limit theorem.
Okay, so let's practice the central limit theorem and see what we can come up with. So this is saying visualizing sampling distribution. So on the right, try creating sample distributions of different summing statistics from samples of different distributions. So which distribution does the central limit theorem not apply to? Okay, we have discrete distribution, continuous uniform distribution, and binomial distribution. And we learned all about these different type of distribution from previous lessons. So we look at the normal distribution here. I think we looked at the binomial. You can see the discrete distribution, the continuous distribution in the previous lessons. So let's see if central limit theorem applies to them. So it says, you know that the central limit theorem states that the sampling distributions of a statistic becomes closer to the normal distribution as the number of trials increases. So if I increase this number of trials here, and I look at this is the mean, sample mean, but we're after the we want to see the distribution. Because this distribution looks like a bell curve shape, so it's closer to the central limit theorem. So if I change this distribution to uniform to continuous, we have the same thing. What about normal? We have discrete here. We have normal. You don't have normal here. We have binomial here. Let's see. So it is closer to the mean. It is a bell curve shape. What if I increase the sample to 1,000? Same results. This is a normal distribution. Normal, uniform. You can see bell curve shape. Then let's do the discrete. So as we have same results. What if I increase it to 1,000 to 5,000? Let's see. So definitely all of the above. It applies to all of the above. Ooh. But okay, it said does not apply to. So I'll go for the binomial distribution. No. That means when it applies to all of the above, that means it does not apply to none of the above. Exactly. So the normal or the central limit theorem it applies to discrete uniform distribution, continuous uniform distribution, and the binomial distribution, since they all return a bell curve shape. So interesting. So victorious visualizing. So regardless of the shape of the distribution, you are taking sample mean from. The central limit theorem will apply if the sampling distribution contains enough sample means. You get now. So as the number of trials increases, it becomes closer to the normal distribution, no matter the type of distribution you're looking at. So let's see the CLT in action. It said the central limit theorem states that a sampling distribution of a sample statistics approaches the normal distribution as you take more samples, no matter the original distribution being sampled from. So in this exercise, you focus on the sample mean and the central or limit theorem in action while examining the number of users column of Amil deals. So we have access to the Amil deals data set here. So this is this data set, Amil deals. So you can download the data set following the link under the YouTube description. So we want to focus on this column, this number of users column. I think the previous lesson we really focused on the amounts column for our analysis. You can see the amounts column. That was what we use for this analysis. So let's focus on the number of users column in this instance. So on the Amil is close, which contains the number of people who intended to use the product Amil is selling. So the focus will be on examining the number of users column, which contains the number of people who intended to use the product Amil is selling. So pandas is imported, numpy or matplotlib, and abilities is available. So I have all those also imported here. You can see all the way from here. Let's just run the line of code again. Okay, we're on track. So the next thing is to follow the instruction. You say create a histogram of the number of users column of our mail deals and show the plots. So I want to create a histogram of the number of users column of our mail deals and show the plots. So I think I have created something like this here. So let's see. So if I run the code, let's see. Oh, my own name here is called Amil deals. Okay. So this is the histogram of the number of users in this column, in this column here, this number of users column. So this is the histogram, a visualization of the record in that column. And see we have less, this will be number of deals. This will be number of deals by number of users. Get now. So 0 deals, we have over 30 users. You get it now. Let's move ahead and see. Let's submit the answer. Amil deals. Okay. Did you call Amil deals? .txt. Yep, let me check. So it's asking me to use another line of code. So different line of code work for different scenario here. Let's get help on this. Just say Amil this number of users.txt. Okay, let's follow. You will see that we will surely have the same results as this. Let us just copy this line of code here. So we have the same result. You get it now? Um, let's see. Amildus.ext. Okay, hold up. Dot is okay. Can see the result that we have here. Well, you're still showing the same result. Why is it not get accepting my answer? Mm, okay. Create a histogram of the number of users in Amildus. Just a second there. Okay, let's see what we have here. So my result is showing me the number of users. I show the plots. An histogram of the number of users. So what am I having here? Let's see. So let's say PLT dot east, open brackets, Amildius. Let me just copy this. Amildius. Don't focus on the number of users column. Number of users column. So let's run this and see. You see, I'm getting this another color. Uh-oh, come on. Amildius dot east. How am I getting this same error over and over again? Let's see. I'm trying different line of code. Oh, okay, let me check. But it's going to be the number of code that I'm using. It could be a single quote, it could be double quotes. Yeah, come on. This is showing me the record in the histogram column. So am I running into an error over and over again? It's showing me the same error. Amildius. What if I copy this solution? Let's see. Okay. We're having the same results. Come on. I see that something is wrong somewhere. It's definitely not me, but let's try to troubleshoot the answer so you can move ahead. There's something is wrong somewhere there. And this is not showing me on Instagram. Uh-oh, come on, what could be the problem? This is definitely wasting my time. Okay. Did you call amildews.east? Okay, let's call amildew.east then. Let's call amildew.east. Dot east. And just number of users column. No users column. We're having the same results. Uh-oh. There's something is wrong somewhere. Okay, okay. Plt.show. Oh, so I've seen my mistake there. Okay, I think it's better. Voila, so we got it finally. So the error was coming from my mail deals dot histogram then plt.show. Interesting. Let's move ahead. Essence of troubleshooting. So set seed to 104. Take a sample of the size 20 with replacement from the number of users column over mildews and take the mean. Okay. Hope I can get rid of this. So we all can see this very well. Oh, no, I can't. So let's see, make use of it. Okay, so we have to set a seed. Set seed. That will be np. That will be numpy dot seed of 104. So the seed of 104. Type np dot random. So with the random dot seed of 104. Then we will take a sample size with 20 with replacements. So we're going to take a sample mean of 20 with replacements. Okay. Sample 20 is going to be np dot random. Let me just make this a little bit smaller. So hopefully you can see what I'm writing there. Yes. np dot random dot choice from our mildews. Then we stick to the number of users column. Then the size is going to be 20. Plus 20. So you say take a sample size with replacements from number of users column over mildews and take the mean. The sample size is 20. I'm going to replace with replacements. Replacement is going to be set to 2. So I want to take the mean. Let's now take the mean of sample 20 or sam 20 dot mean open and close the bracket there. So let's run the code and see what we have here. So the mean is this mean of the sample 20 sample size we took was 32.0. So that's correct. So we nailed that. And now say repeating this 100 times using the for loop and store as sample means. This will take 100 different samples and calculate the mean of each. Okay, now let's recreate that. Okay, let me minimize this. So we've set a random seed of 104. We've taken a sample size of 20 with replacement from the number of users column in our mildews. Then we look at the sample, the mean of those samples. Now, once we create this scenario over and over again 100 times, let's see. The sample mean is going to come with a for loop. So if I can widen this a little bit. Okay, I think this is better. So sample mean is going to be, so if you have a random seed of 104, so loop 100 times for I in range of 100. It's going to be 100. Take sample of 20 number of users. So np.random, we're going to equate this. Come on, where is that? Going to be np.random dot sample. Now we're going to be samples or quiz choice there. Choice, open bracket, amildews. Then select the number of users column. Number of users column. Then our size is going to be 20. Size is going to be 20 with replacements. So replacement is going to be set to 2. We're going to set to 2. So what we need to do, calculate the mean of sample 20. So mean of sample 20 is going to be sample 20 np mean, np dot mean of sample 20. Sample 20 is append sample 20 mean to sample means. These are sample mean here. So sample mean dot append to sample 20. Sample 20 mean, which is this sample 20 mean here. Where does sample 20 mean? This sample 20 mean. Now let's print means. Okay, let's run the code and see. Oh, number of users is not defined. Why is that not defined? So what mistake are we making? Come on, come on, come on. Let's explain this error. So sum 20 means, okay. Oh, it's supposed to be equals to here, not that. So that's where my error is coming from. You could see that. So my error is coming from this side. Rather than saying equals to 20, where is that? I used the wrong. Oh, still getting the same error. Size equals to 20. Where is that? Size equals to 20. So my error is coming from where? The error comes from the following part of code. Sum 20 np random dot choice amildews. Number of users size 20 replace is 2. So it's supposed to be sum 20 amildews. Oh, okay. Sum 20 np random dot choice amildews. Number of users. Oh, wait a minute. Oh, my number of users is not wrapped in quotes. Oh, sorry about that. Just a quote discussing a mistake there. Now I can say our sample means of 20, so we know that. We have to be pretty careful with the line of code that you have here. So let's submit and see what we have here. Oh, great. So finally, convert sample mean into pd.series, create a histogram of the sample mean and show the plot. We need to convert this sample mean into series and plot histogram. And plot an histogram to visualize the results. Okay, we are getting there. So sample mean, we want to convert it into a panda series. So it's going to be panda.series, the sample mean, that is sample means. Sample mean, so sample means underscore series equals to dot is, going to use a histogram dot is, then create a histogram with the sample mean and show the plot, then plot dot show here, dot show. Okay, let's run the code and see what we have here. Well, we have our results here. Ooh, we have a single line of the mean here. Let's see if you got that correctly. Oh, PD dot series. Did you correctly specify the first argument? So PD dot series, what do we have here? Sample 20 mean. So what are we supposed to show there? Oh, I'm supposed to just sample means, not sample 20 means. Sample means, oh, sorry about that. Sample means, not sample 20 means. Let's run that again. Voila, see our result here. Oh, great. Fabulous job. You just seen the central limit theorem at work. Even though the distribution of number of users is not normal, the distribution of each sample mean resembles the normal distribution. Interesting. That's a lot of challenge here. So the means of means. Let's understand this concept of the means of. Let's look at this. The means of means. It says you want to know the average number of users. You want to know what the average number of users is per deal. But you want to know this number for the entire company so that you can see if Amir deals have more or fewer users than the company's average. The problem is that over the past year, the company has worked on more than 10,000 deals, so it is not realistic to compile all data. Instead, you estimate the mean by taking several random samples of deals, since this is much easier than collecting data for everyone in the company. So Amir deals is available and user data for all companies is deals is available in all deals. So let me recreate what I did here in this health in action. I'll have to recreate it all the way from here. So we've done that here. We've done that here in pandas, Jupyter notebook. So I'll just go ahead. I'll set a seed. I just have to try it out in my so oh mine is not meal deals, so mine is sales here. Mine is sales. The data frame here is sales. Sales. So these are our sample mean for that random seed that we set. Now let's continue from here and see what we have here. Oh, I always forget. Mine is sales. Sales, then finally here also sales. So you can see our random mean. These are just randomly generated. Then we could finally just pick this, convert it to a plot. Convert to a plot. Okay, now let's show the plot. Let's see. So we have the same results here, like we had on our end over there. So you can also try it out to see if you get all these results in your Jupyter notebook. So let's move on. So our the means of means. So it says Amir this is available and the user data for the company this is available in all these, both pandas as PD and NumPy as MP. So let's try to solve this final challenge. We have like 4 challenge to solve here. So we need to set random seed to 3 to 1. So np dot random dot seeds maybe set to 3 to 1. 3 to 1 for that. So now we're going to take samples, take tally samples with replacement of size 20 from all our mail deals number of users. So I'm going to take 30 samples with replacements. Okay. And take the mean of each sample. Store the sample means in sample means. Okay, so this sample means equals to a loop. It's going to be for in range. Take the 30 samples. It's going to be 30 samples. So take loop 30 times to take 30 means. Then take sample of size 20 from number of users column of all deals with replacement. Number of users column of all deals. So all deal is called all deals, right? All deals is equal. So I want to take 20 samples from all deals and loop 30 times. Okay. So it's going to be 20 number of users dot sample. So our sampling is going to be 20 samples with replacements. Replace is set to 2. Replace is set to 2. Then finally store the sample mean in sample means. So we want to take the mean, okay, and take the mean of each sample. Take mean of couple. Okay, so call mean or call sample rather dot mean. Then we need to append call mean to sample means. We need to append call means to sample means. Let's see. Sample means dot append. They want to append call means here. Our call mean. Then print mean of sample means. Print means of number of users in amenities. So print mean of sample means. So it's a print the mean of sample means. Print the mean of number of users column of amenities. So the mean of sample means. So we're going to print this out. Let's see what we did here. We did something similar here. Okay. Mean of sample means. Print sample means. Sample means. We've taken the mean here, so then print the means of number of users of our mail deals. Okay. Our mail deals. So our mail deals is going to be mail deals underscore deals. Then number of users column. Users column. Dot mean. So let's see what we have here. Voila. So this is the mean of sample means. Where is the mean of our mail deals? This is the mean of our mail deals. How about the means of the sample mean that we have here? Let's submit and see. So we have some error somewhere here. It said, did you call np dot mean? Okay, let's get help on the error. So np dot mean, oh, okay. np dot mean the sample means, okay. So I didn't get the result. So see the difference now. So the sample mean from our looping is 38.3, while the sample means of our mail deals users is 37. Oh, magnificent mean calculation. Our meal's average number of users is very close to the overall average. So it looks like it's meeting expectations. So this is the overall average from the company, after looping, taking a sample, a number of users, samples, multiple samples to arrive at the average at the mean. But this is a mean or average or mean, which is closer to the company's mean. Interesting. So that's how you take samples. So you need to understand to take samples, random samples, and calculate whatever you need to calculate. Ooh, that's a lot of lesson. Definitely will be reviewing lessons over and over again. But I don't have access to these audios from the company, so I can't replicate what I did here. I can replicate it in this instance here. But the most important thing is to know how to loop, how to take sample means from without replace. This is with replacements and calculate the mean of what you need to calculate. So we use np.random.choice here. We also use np, what do we use here? Dot sampling here. Dot sample here. Okay, interesting. I could always go back to this. Let's continue. Okay, we want to look at the Poisson or Poisson distribution. So that will be on day 50 live stream. So we can just cover this lesson, the Poisson distribution, identifying lambda, tracking lead responses, more probability distribution, distribution dragging and dropping, modeling time between leads, the T distribution. Okay, so that will be the end of the live stream for today. We're going to continue from here on day 50. Alright, so thanks for staying to the end of the live stream. So if you enjoyed this learning journey of Python with me, I'll do well to give this video a thumbs up by hitting that subscribe button and put on your notification bell so you'll be the first to know whenever I go live or drop a new video on the channel. As usual, I'll see you in the next video or on the next live stream. Do have a wonderful rest of the day and let's get back to work.